This is going to be about graphing tangent and cotangent. If we look at the tangent identity, it is sine over cosine. And so whenever cosine is 0, we're going to end up having vertical asymptotes for tangent. So when you think of your cosine graph, like so, well, when cosine is 0, maybe I'll go ahead and pull over to this other side, then tangent is going to have vertical asymptotes at those values. We then would have to look at the relationship between sine over cosine, noting that these are going to be at negative pi over 2 and pi over 2, and then 3 pi over 2, and all the pi over 2's, if you will. Noting that I know at my pi over 4's, I'm negative 1 and 1. And then at 0, I'm 0. And so my graph should look a little something like that. And it is a periodic function. So every pi chunk between negative pi over 2 and pi over 2, every pi chunk is going to be a repeated piece. Now we can shift tangent just like we've been doing with all of our other cosine functions and apply period shifts and so on and so forth. So let's look at this example here. So amplitude -2, well, amplitude of 2, so a stretch of 2. I'm also going to have a flip over the x-axis. Let's look at our period here. Okay, so our period is going to be 2. And then if I factor out that pi, that's a nice factor there, I'm going to move to the left 1. And then I'm also going to move this function down 1. Okay, so let's just look at one normal period of tangent would look like this. Now I'm going to change my period to only be 2. So that period has to be repeating so that that length is 2. So then this must be negative 1 to 1. Then I also need to move this to the left 1. So I'm going to move my 0 here. So now my vertical asymptotes would be at negative 2 and 0. The next thing I need to do is flip and stretch and then move down 1. Let me change. So the flip and stretch means it's going to go, there we go. Okay, the flip and stretch means it's going to go kind of more like that, but then I have to move it down 1. So a little something like this would be our graph of one period of pi. Then you'd have another one that would go from 0 and then to 2, and then it would kind of do that same thing here. Okay, all right, let's look at cotangent. So cotangent is just 1 over tangent. So notice that if I then have vertical asymptotes at pi over 2 or negative pi over 2 and pi over 2 for tangent and a 0 here, well, now that's going to all switch. Also, wherever tangent is negative, cotangent also has to be negative. So notice that's a little bit different as well. And my vertical asymptote has to move to here. So the other way you could also look at it, if the 1 over tangent is a little bit confusing, is cotangent of x is also cosine x over sine x. And so where sine is 0, cotangent would have vertical asymptotes there. All right, so let's go ahead and graph one of these transformation pieces. So cotangent normally has it always has a period of, the parent function always has a period of pi with vertical asymptotes at 0 and pi, and then a 0 at pi over 2, and then it kind of looks like a flip of tangent, okay? All right, well, now my period needs to be pi over 8. So let's just do that. And then if I factor that out, because I have a shift as well, okay, that's going to be 4. So this whole thing is going to get moved over 4. Let me just draw a new thing. So instead of being at 0, oh, it's going to be moved to the right 4, excuse me. So instead of being at 0, now that asymptote is at 4. I still have a 0 here. And then this asymptote is at 4 plus pi over 8. 42, well, let's not worry about adding those, like that's just a number. So let's just leave it at that, okay? All right, then I have to move this down 2. So instead of the 0 here, I'm gonna move it down 2 and then stretch of 4. So that graph would look something like this.